Welcome. I'm going to show you a frequency sweep. We have this audio transformer here. It's an audio amplifier, much as you'd find in a car. And where the speaker normally goes, I've got one wire going through a current meter through both prongs of this transformer, and there is no speaker. And then it goes out through these two wires, because I have one wire going to one side of the transformer and one wire from each coil through two globes such as that, and then the wire from the other side of those globes goes through a single globe and back to the transformer. So conventionally speaking, what we should see is this globe will be the brightest because it comes straight from the transformer. This should be the brightest, then it branches off into two globes which should then share that same current. So those two globes should be the sum of that one globe, and then through the transformer and meter and back to ground. So this globe should always be brightest. And I'm going to start the frequency sweep. 25 Hertz, 26, 27, 28, 29, 30 Hertz. And that is indeed what we see. 10 volts, that's going across the entire output of the amplifier. And 240 milliamps. So, now both these globes are on as it should be. We're up to 84, 85, 86, 87. Not much going on the ammeter, not much going on the voltmeter, and the voltmeter should stay roughly the same throughout the test. The ammeter, however, has started to drop and will continue to do so. And the light globes have now changed a bit. That's still quite believable. Those two roughly equal to that one. However, if you can listen carefully, hopefully you can now hear the frequency. The transformer is starting to do some work, and oddly enough the light globes at 700 Hertz are not doing what we might expect them to do. So we seem to have some power oscillating around in circles around this transformer, and the loop of light globes, instead of going right through the circuit and back out again, we have some kind of resonant loop of power going on here. I'm not claiming over unity. It is called the Mr. Preview experiment, and I've done it before with a number of different cores, including iron. However, I'm going back to this because if you watch my last video, I inserted a clip of someone doing a very similar experiment to this with a met glass core. And there we go, that's the frequency sweep over. And they found an exact frequency where the input current dropped to zero, almost zero, and the oscillation in the core was still so powerful that the light globes were fully glowing. Fascinating. So I'm trying to get my mind around just how that was done. Despite having been able to have the opportunity to ask quite a few questions, I've not been able to get that. But I've ordered a very similar core to what was used. So I'm going to keep trying to replicate that because that seems very significant. And I'll check back in soon, let you know how I go. But the next clip I'm going to insert is of me performing the same experiment again, with the same frequencies that it was doing anomalous things, however with a square wave DC being switched in by a transistor and a signal generator. So I'm going to try and replicate this with a square wave DC and see what happens. Okay, I've just rerun that experiment with an off-the-shelf signal generator. It's clean enough, I think. I run it with 10% duty cycle. all the way up to 50% duty cycle, and that was the result I got all the way through the range, completely as you would expect. Yeah, no resonance behavior whatsoever. Does not work with square wave DC. Okay. I've got quite a few more fails to document because I've been busy at them, and hopefully I'm going to find a few successes to share as well. Thank you very much. Just a quick bit of background information. The experiment I referred to before about the zero input current and the very high output power circulating, that was done, as I said, with a different core, but the resistance being used in that instance was 1.5k and 500 ohms and 24 volts in. So that's a bit of a wow, because at the moment the coils I just showed you were low resistance, 50 ohms and 150 ohms. Now that worked quite well because you can actually push some current through there. These set I made a couple of days ago and have been testing, trying to get them working. This is about 360 ohms and 120 ohms. So only about 20% of what our other boy was using. But even at 30 volts, I can't push enough current through the circuit to get any light at all. And nothing on the frequency sweep. So I'm going to try see what we can get with square waves through there as well, because I did notice a few anomalies with square waves. But yeah, as it stands, that larger amount of resistance and a frequency sweep, I got nothing, even with the similar kind of circuit. So let's try the next step. Square waves. Well, it's difficult to remember just what conventional means, but I think this is conventional. At 30 volts DC square wave, 50% or 40%, we're pushing 150 milliamps. Previously under AC, it was not reading on the meter. It was basically no AC current was able to be pushed through there. So as a result of that, we do have some light. But yeah, this globe is the brightest, and there appears to be no resonant action occurring. So yep, that's a fail. DC with the high resistance. One of many. So let's see if we can take a big jump next time. Okay, so far in this video alone, we have been using this circuit here. Got your parallel lobes, your series globe, and your series transformer. Now in theory, you get it to the right frequency and you start having some power oscillating around in there, and hopefully you get more around in there than you do throughout the whole circuit. I may have proved that trying this earlier with a different kind of transformer, but if so, it was only about 120% efficient at very best. So now, this is the circuit that performed the magic as demonstrated by my dear friend. This was more than 120%. I think he got his to something in the realms of 20,000% efficient. So I've already tried this circuit with a great many transformers, including this one here. But I'm going to persist because my new core material is going to be arriving next week, and I get to try it with a more hopeful candidate. However, I was pretty sure that this circuit should work with high frequency ferrite, but I was pretty sure that this circuit should work with high frequency ferrite cores, such as that and many others. However, my frequency sweep does seem to be fine for some ferrites. However, because it's only going to about 15 kilohertz, it's entirely possible that it's not enough. However, the amplitude of all these cores was tapering off and hitting about 0 by the time it got to 15 kilohertz. So it might be hurting the situation, it might not be, but I'm going to proceed. Certainly this circuit with ferrites and with iron cores was working, and I was getting some oscillations. But this one, maybe to make it work, I need higher frequency cores, quite possible. So I'm going to move on and find out. Well, I've downloaded some new computer software that allows me to run a frequency sweep more slowly. So I've run the sweep over the course of 4 or 5 minutes, and that's let me keep an eye on the meter for current peaks that go low when the lights go high, and I haven't really found any. I've gone ahead and applied this circuit to the different resistance coils I've got, and nothing as well. So I'm going to turn over the page, try another core I've got with actually with both of those circuits, and I've got another circuit taken from one of Stanley Meyer's patents, because I have a suspicion he was doing exactly this with these reversing coils, also seen in some of Tesla's patents and many others. So there's something to this. I've seen something. The question is, why isn't it working more readily, and how can we make it more consistent and better? So, continue the search. Well, this experiment just turned into a ripper. This circuit here. I now have 2 globes running with this circuit through this core. So that is currently running at just under 300 milliamps and 8.5 volts. This globe, which looks exactly the same to me, is 8 volts and 300 milliamps. However, this one's running from my perfectly conventional power supply, and this one is... where is this one running from? That's a mightily good question. It's running obviously from this audio transformer. I'm pushing a sine wave through this, and I managed to fix up one of my old signal generators because I had a problem. I haven't been putting enough frequency through these things, and yeah, no, I kind of don't have any money at the moment, and yeah, a bit of a problem with signal generators, despite the fact I've got a nice new 4-channel scope. But anyway, I'll get all that sorted out eventually. But yeah, I seem to be powering 2 globes for the price of 1 globe, and to me they look like exactly the same brightness, and because I've got the frequency set to exactly 27 kilohertz, which looks ideal for this transformer, I seem to have a peak right at 27 and it goes down just after. So there's a nice peak there, and yeah, there you go, look at that. 2 globes for the price of 1. It's a good start. So, see where we take this next. Well, this little globe here, DC 250 milliamps and a whisker over 6 volts. Now, these 3 globes here, I'm not sure if I'm measuring them correctly, because I'm not sure quite how to measure a tank circuit, but basically the voltmeter is going from one side to the other side of both the light globes and the transformer, forming the tank circuit. And these ones say 9 volts, and I've adjusted it so they look like the same brightness, 9 volts and 250 milliamps, compared to 6 volts and 250 milliamps for a single globe. And I also notice when prodding around with an earth wire, it goes completely berserk. So yeah, we'll find out where that goes in a couple of minutes, hopefully. Oh, and I should note, with this configuration here, with the 3 globes for the price of 1, and the previous experiment 10 minutes ago with the 2 globes for the price of 1, they were with this bottom circuit with the 2 spacers removed from the core. So the core halves are literally touching each other, no spacing. And that makes a difference. But I have no idea why just yet, so in the future we shall soon see. I've just liberated this core from a TV flyback and printed 6 of these guys. So I'm going to be running some more tests, but I suspect the devil is in the detail actually, because I think I can probably get a lot more out of these ferrite cores than I currently am. I just don't know how. So we're going to have to stay tuned and work that out. Thank you. Hey, by the way, did you know Kaylin, Jaden, and Ashlyn all have their own... Oh, fuck, I'm overloading this thing. Seems very easy to do. All have their own YouTube channels. The SSG legend is back. I thought I had them all. No, more power. You must raise the voltage. Okay. Once upon a time... Oh, by the way, it works with square waves. That wasn't the issue. Works just as well. Okay, now I'm fairly confident this stuff can be replicated quite easily. This here is a ferrite transformer taken from a 200 watt ATX power supply, and that worked very well with this circuit here, both with 2 and 3 globes. So this is the circuit I used a couple of months ago with my Mr. Preva experiment, and that was with a flyback transformer core. And this circuit was also quite successful, also very easy to replicate. Just dial in the resonant frequency of the transformers. Now I'm not sure this one was over unity. It wasn't quite so obvious. It was maybe only 120%, whereas this one is quite obviously significantly over unity. And the reason I've gone back to simplifying these things rather than some of my previous very advanced circuits is that I ran into a real stumbling block the last couple of days. I made this filter. It's just got a pile of inductive and capacitive networks inside of it, because my power supplies, albeit handmade, have been very rugged up until this point. They've been almost indestructible, but when firing this transformer here with a square wave through a transistor, once it got up to about 15 or 20 volts, it started behaving in a very strange manner. It started going haywire. Basically, I think what was happening is the extra energy from this circuit here actually was backfeeding the power supply, and although the power supply was set for 15 or 20 volts, the needle just went straight up, and yeah, and my scope wasn't reading it properly. My scope was jumping around all over the shop, and basically it blew the power supply. So yeah, since that happened, I wanted to try and stick some diodes in around the place and see if I can keep the magic and prevent the explosion of the power supplies. Despite the creation of some new hardware, I've not managed to do that. As soon as I started filtering out the problems, all the goodness went away as well. So now that I've refueled my ego with a bit of success here, I'm going to go back to something closer to what I've seen on the internet, which is removing, or putting the input back a bit and having some bipolar capacitors in between. And although I've tried that with electrolytics without much success, I've seen a circuit online where people are using bipolar capacitors, and the backs and forwards resonant waves are charging the capacitors, and And then in a slightly better manifestation, they've actually completely removed the power supply, and it self-sustains. So although I'm nowhere near that yet, I do want to make some experiments moving in that direction. So now that I've explained that this basic thing here over Unity circuit can be easily replicated, we're going to try and take this kind of thing to the next level. Okay, that's the idea.